Hi, everyone, student. Can see me or not? Sorry, I go to share my screen first. Okay, can see my screen or not? Okay, morning. Okay, I go to change my layer first. Okay, hello, Katija, morning. Okay, I can see my screen, Okay, wait, I go to change a while my layer first. Okay, this one. Okay, hello. Hi, Iru. Can listen? Okay, can listen me also, Okay, I go to slideshow. So today I want to do some calculations. So hopefully you prepare your calculator. After that, you give me the answer lah. Okay, so I go to slideshow first. Okay, this one should be the last one for your chapter 7.1. Then later I want to go to 7.2 already lah for the next lesson. Okay, so hopefully the student, you still remember this one formula. Okay, we recall back about the photon concept. Okay, photon concept, that means there's a wave particle duality. They take as a wave. There also can be a particle. Okay, so that means they got two characteristics lah for the photon. Okay, so from here you need to remember the three main formula we learned before that. Okay, first one is the photon energy. Okay, there's a Planck and also the frequency. You also can change about the frequency is a speed of the light over the lambda. Okay, over the wavelength. Okay, number two is a photon power. Photon power, they add one of the physical quantities. There is a per second. That's an n. Number of the photon per second. So, excuse me. So they're just n, h, and f. So you also same lah. The frequency, they also can be convert c over lambda. Okay, and the last one should be from the de Broglie. The one they produce the momentum. Okay, they're talking about the momentum. Okay, so from here they say the lambda equal Planck over the momentum. Okay, related with the momentum and also the wavelength. So from here, momentum, we also can write that as a mv. Okay, that as a mv. Okay, so from here we go through to the next. Okay, example 4. So we straightforward today go to calculations. So hopefully you remember the just now the formula. So we straightforward to do the calculations today. Okay, first one, we're going to see the lamp. Okay, the provided is a power, 50 power lamp, emit the red light. Okay, the light is a red color. Then the wavelength is 7 times 10 power of negative 7 meter. So they ask you what is the number of the photon. Okay, what is the number of the photon they emit per second? So actually they want to find is n. Okay, before that we're talking about the n per second. So from here the question provided power. So you must think about the power formula. Okay, just now that 2 power formula. So I recall back this one. So we need to think about this part lah, because they want to find about the power, is it? So the question just now, Planck, you need to remember yourself. 6.63 times 10 power negative 3. Okay, sorry, negative 34. Okay, then the F. Then after that, the N. If the question never provide the F, then we're using C over lambda. Okay, now we're going to see the question. Okay, the question is provide is what? Wavelength. They provide is a wavelength. So from here, that means speed of the light you also need to remember. Okay, so we're going to see the info first. Okay, forget to tell the student, actually today, if you want to recall back the exercise, actually I put the description already. Okay, I put at the description, you can go there and see it. They got one of the link. Okay, one of the link. Okay, I go to copy first. Some student, maybe they want to do the revision. So I just put here, so student can see it. The link is here. Okay, the link is here. So actually today the exercise all is here lah. So from here you can find it. We get the info. Okay, first info there should be the blank lah, 6.63 times 10 power negative 34. Okay, then after that the next one should be the speed of the light. So every student know lah, the light may need 3 times 10 power of 8. Then the power also 50 watts. So the student please ready, ready to press your calculator already. Okay, then the lambda. Lambda already is 7 times 10 power negative 7. Okay, now is n. What is the number of the photon emit per second? Okay, emit per second. So from here, the student, please, we need to show about the formula lah. Okay, we're using this formula. P equal N, then HC over lambda. Because we don't have any F. Okay, we just can using C over lambda. Okay, so the student, please press your calculator and give me the answer. Okay, for this question. Okay, so I want to find is the N. So you need to change the positions. Put the N alone, then bring the P to another side, then you find the answer. Okay, so when I just put N alone, so become like this. Okay, power multiply the wavelength over the Planck constant multiply the C. Okay, so the student on the line now, can you please give me the answer? Can you show me the answer or not? Okay, I want to check the student. You can apply or cannot apply. For this one, topic 7.1 normally is a calculations lah. If not, they ask about the concept, they might ask a scientist what they create, what they produce, or something like this. Okay, so from here, I get the answer from Cha Yao. Okay, Cha Yao give me already. Okay, remember the N got unit. They say per second already, so that means got unit. Okay, Cha Yao give me the answer is what? 1.760 times 10 power of 20 per second. Okay, so we just apply all the thing in. Okay, all the info you list out, then you just put in. Okay, after that we go to show. 1.760. Yeah, correct. Jia give me 4 significant figure. Okay, Ling Han also same. Ling Han, 1.76 actually is okay lah. Okay, if they say 4 significant figure, so better we put 1.760 power of 20. Okay, then after that, remember the unit must put, okay, per second. Okay, so this one is the answer for the example number 4. Okay, so we continue with the next one, example number 5. Okay, example number 5, you see the question. Okay, so from here they say a red laser pen emit the light with the wavelength. First one they provided is a wavelength. So must remember the N. N is a nanometer. Okay. Yeah, Khatija also give me the answer just now. Yeah, correct. Okay, if the number of the photon they emit is a 3.37 times 10 power of 18 per second. Actually, this one is what? This one is an N. Okay, you might understand the question. So what is the output power? Okay, the question I want to find is a power. Okay, so what we need to know, we need to list out. List out all the things. Planck, I call you already. The Planck, you must remember the constant number is how many. Then the speed of light, you also need to remember. Okay, after that, we key in all the things. N is how many? 3.37 power of 18. Okay, after that, the lambda also provided. So I want you to convert. Nanometer convert become the meter. Okay, so from here, we find it. There's a power of the suppose it's a 9, is it? Power of the negative 9. So I go to move. Okay, I move becomes standard form. Then becomes 6.7. Okay, multiply the power of negative 7. Okay, so from here they want to find power lah. So actually we just using the just now formula. Okay, they just change the positions only. Okay, so from here I still apply the same thing. P equal NHC over lambda. So from here, we straightforward apply. Okay, so the student here, anybody can give me the answer for the P, power of this one laser pen. Okay, power of the laser pen, we need to find out now. Okay, formula is the same. Okay, Yiru say 1.00 watt. Okay, so we go to check is it correct or not. Okay, Jiawei also same. They say 1.00 watt. Okay, we go to show. Okay, all the thing in. You see, so complicated the calculation, got so many things into press. So you need to press one by one. Okay, after that, they're over the lambda. So from here, we go to show, yeah, the answer is 1.00 power. Power unit is what? Watt. Okay, there's a watt. Okay, so Jiawei and also Yiru also correct, the answer. Okay, then we go to the next question. There should be the example 6. Okay, let's see the example 6. So from here, now the question got a little bit different. They put, assuming that 10% of the power output of 100 watt. So you need to take 10% from the 100 watt lah. Bulb is emitted to emit how many? The photon, they say told you already. The photon per second. So this one means N lah. Okay, this one is an N. What is the average, the wavelength of the light in nanometer? Nanometer. They say they need to answer in nanometer. So from here, this one should be lambda. You need to find the lambda. So that means we need to find out 10% from 100 watt is how many first? Okay, because there is a power. Okay, we need to find out the power output. Okay, so from here, I show the info first. Okay, still the same. Number 1 is a H. Number 2 is a C. Okay, N is how many? We just copy from the question. Okay, P1. P1 means input. Power input is 100. Okay, then the lambda is nanometer. But we don't know how many lah. So from here, we need to show, we see the info first. We got P, we got lambda, we got N. So normally using the same formula, is it? Wow, very fast. Chaya give me already 581. So we go to check. Okay, so we're using a calculation for the output first. We calculate the power first. Okay, the power is a 10 watt. Okay, so we apply the same formula just now, but now I want to find is a lambda. So I just write the calculations. Okay, put in all the things, but the power now not 100. The power is a 10 only. So we go to show. Okay, we go to check. Is it the Jaya answer correct or not? Jaya give me is a 581. So we go to show. Okay, so this one should be the answer in meter. Okay, I think I forget to write the answer in the nanometer. So if nano, that means lambda should be equal. Okay, I change become nano. So I become 581. Okay, after that, times power, no need to times already because this one already is nano prefix. So no need to times. Okay, straightforward, you go to write about the nanometer. Okay, so that one should be the answer. Okay, so the Chaya answer should be correct lah. So from here, important, if the question say nanometer, so we need to convert. So if you just write until this part, you're halfway only. So maybe question is 2 marks, you get 1 mark. If the question is 3 marks, you get 2 marks. So like this lah. So must read be careful for the question. Okay, so we continue. Oh, finally, I got right. I forget it. So that means I got right lah. 581 nanometer. Okay, then we go to example number. This one is a question 1 already. No example. The chain become question 1. So what is the energy of a photon with the frequency? Question give you frequency. They want to find is an energy. So never talking about power. Never talking about the lambda. Only energy and frequency. So this was normally we using the first formula from the Planck. There's a photon energy. So we go and see the info. Okay, H and C is a fixer. Then how about the F? F is a frequency, 10 power 24. Then we need to find is a E. Okay, what formula we need to use? The simple formula we need to use is a the theory of the Planck. There's an energy photon E equal HF. Okay, so from here to find is the energy lah. So energy, the unit must be joule. Okay, so from here the student, okay, simple question, just apply here. Okay, so we're going to find out the student got answer or not. Okay, very simple only. This one question is compared just now is more complicated, but this one still okay lah. Multiply only. Okay, you take the Planck, multiply the frequency. Okay, the frequency 10 power 24 actually means what? 1 multiply 10. Like this. The question never mentioned the in front, means that only is a F actually is a 1 multiply the 10 power of 24. This one is a meaning. Okay, they never mention in front only. So there's a hertz. Okay, we get the answer from Yiru already. Katija also. Okay, we go and check the answer. Is it correct or not? Okay, I put in all the things. E equal or multiply or Sika Jing also got. Ling Han also show me. Okay, power of 24. Then I go to show the answer for energy. Okay, yeah, correct. Okay, 6.63 power of negative 10 joule. Okay, so got many students also show me the correct answer. Okay, so from here, this one just simple. So hopefully the student understand that normally the 7.1, they will come out the calculation like this. Okay, so we go to the next part. Okay, next part is a question 2. What is the energy photon for the wavelength is a 10? Now the question give you lambda. Okay, so just now is a frequency. Now give you the lambda. So that means we need to change the formula already. Cannot using the F. So you must using the, convert the F become C over lambda. Okay, so the info still the same. H, C. Okay, but now extra one more. There's a lambda. Okay, no F. So we're using what formula? We're using this formula. E equal H, C over lambda. Okay, so from here, HC over lambda means you need to apply the formula. Remember, the 10 is nanometer. So you need to convert nanometer. Okay, become 10 multiply. Okay, 10 power of negative 9. This one is a nanometer. So you need to convert, multiply. Then after that, you give me the answer for photon energy. Okay, there's no problem for the student. The calculation should be the same. Okay, just the number quite a bit. Okay, quite big a bit. So when you press the calculator, remember you put the bracket. Okay, so the Yiru show me already 1.981. Okay, 1.981 power of negative 17. Okay, we go to show. Okay, put in the Planck constant, put in the speed of the light, then divide by the lambda. So we get the answer 1.989 power of negative 17 joule. Okay, so Kai Xian also correct. Wong Kai Xian. Okay, Chaya also correct. Okay, Chaya, I think got a little bit problem for your power. Power not negative 19. Power is a negative 17. Okay, maybe you press the calculator, got a little problem for pressing lah. Okay, so we go to the next. Okay, the next one is the number 3. Okay, number 3. Okay, number 3, there is a number of the photon emitted per second. Okay, they ask you the N. N is how many? We don't know. Okay, by an ultraviolet light, okay, the wavelength provided and the power also provided. So now the question, they bring the power already. Bring the power, so you need to think about the power formula. Okay, power only got 2 formula. P equal NH. Then after that is a F, is it? So the F you can using C over lambda also can. So from here we show about the info. H and C is a fixed one. Then the lambda is provided from the question. 4 power of -7. Okay, then the power is a 50 watt. So they want to find is an N. So we just apply the same formula for just now. P equal NHC over lambda. Okay, so from here we need to apply all the formula in, then you do the calculation, then you tell me the N is how many. Okay, I want the answer for the N. Okay, student also can do the calculation now. Okay, can get the correct answer. Remember what's the unit for the N? Okay, unit for the N. Okay, there is a number photon per second. So give me the answer for N is how many? And this one is more calculation a bit lah, because you need to multiply the H, multiply the C, then you N and P, you need to change the positions. Suppose like this already. Okay, N is another side. Then P is the power, multiply the wavelength over the H and also the C. Okay, so from here, okay, also same, Yiru give me the answer. 1.01. Okay, then after that, power of 20. Okay, the others, is it the answer same or not? The other comments or not? So I find the student is almost the same here lah. Okay, a long time never see the Lena is enter the room already. Okay, Lena, Lim Jirong, don't know go where already. Then some more, the Nixon, Charan, Hari, long time never see. Don't know where they go. Okay, only the Yiru give me the answer. So we're going to check. Okay, I put in all the things. 50 is a power, wavelength, then over the Planck and also the speed of the light. Okay, Linghan and Jiawei. Okay, Linghan give me the long number. Jiawei give me the long number, 1.006. Okay, for the four significant figures lah. Okay, so we're going to check the answer. Okay, if four significant figure, there should be the answer from the Jiawei, 1.006. Okay, if you put 2 decimal point, it's okay. The question never catch you. But the problem is just get the question is 0.00 something, then you are wrong. So if you're more familiar to write the answer in 4 significant figure, so every time you just write in 4 significant figure lah. Okay, 1.006, power of 20, then the unit, remember, there's a per second. Okay, so the student that apply me from here, the reply almost is the same answer, is the correct answer. Okay, so thank you for your response. So we continue with the next question. Okay, the next question should be number 4. Okay, what is the number of the photon emitted per second? The question they find again, what is the N? They want to find what is the N. Okay, by the ultraviolet light, then the lambda also provided. Then after that, the power also provided. So from here is the same thing. Okay, just repeat only. H and C, then the lambda provided. Then the P power is a 50. Then want to find the N. So we just apply the same formula. P equal H and NHC per lambda. Then the thing we just put. Okay, just a lambda changes only. Okay, power is the same, lambda changes. Then you need to find is a number. Okay, the question is the same one, almost the same one. Just important you understand the question. The formula only that formula. They never change any formula. So that means when the question give you any info, then you just apply the formula, which one should be the answer. Okay, so from here we're going to check. For the student, I think this one also no problem for yours to answer it. Okay, just a simple only. So we just apply lah all the thing I just put 50. Then this one is a lambda. I think it's the same question, is it? So it's the same question lah. So I go to change another part lah. This one is the same question for the just now, is it? Maybe repeat. Okay, so we go to this one lah, number 5. Okay, the human eyes can be resolved about 160 photon per second. So this one should be N. So you ready? Yeah, this one is for B. And 160 photon per second. Then they reach to the retina for the pupil, and the area is okay, this one, area. The question is provided is area. Okay, not lambda, is the area. Okay, if the power of the light per unit area of the monochromatic source. You can see this one not power only. Power per unit area. So that means later you need to disappear the area lah. Okay. Actually, they just want to play about the physical quantities. You can see the unit. Okay, they just want to play on it. So that means later you go to ignore this one and -2. How to ignore? Then you need to multiply about the area, then they will ignore. So you need to determine is the most sensitive wavelength that can be detected by the human eyes. So you need to find is a lambda. Okay, so this one is a question, the info they provided. So we go to show what's the info. H and C is the same. So now N. N is a 160. Okay, after that, the question got provided what's the A? Okay, got A or not? Okay, yeah, got area. A is the area, not ampere. A is the area. 0.5 times 10 power -4. Okay, then extra one more. Power per area. Power per area also provided. 1 times 10 power -12. Okay, got extra info already. Now the question they want to find lambda. Okay, so that means got power, got lambda. We're still using the same formula. I just put the same formula here. Okay, P equal power of the light per area. You want to ignore the area, so you need to multiply lah, is it? You want to find the power. So from here, I go to do the calculation. We find the power first. So I take 1 times 10 power of -12, multiply the area. Okay, as I just multiply the area, I get this one is the power, normal power. Okay, 5 times 10 power -17. Okay, if I get the power, that means easy already. I can get the lambda by using the formula. Okay, so I just apply lambda equal NHC over the P. So student, now it's your job to find for me what's the answer for this wavelength. Okay, wavelength. The question never say there's a nanometer. You can write in nanometer also can. You can write in meter also can. Okay, so we're going to find the answer from the student. Is it correct or not? Okay, this one just do extra one more step lah, because they give you the info got A and power over A. You need to multiply. You ignore the area first. Then you baru can get your power, is it? Then you continue to do the calculations. Okay, anyone here can give me the answer for the lambda? Okay, for this one situation, the wavelength detected by the human eye actually is how many? Okay, we're going to check. Okay, wait the student to answer. Okay, Eric. Eric enter already. Eric, give me the answer 6.369. Okay, so we just put all the info. Okay, 6.36. Yeah, fourth significant figure 369. Okay, then after that multiply. Okay, my answer is -7. Yeah, correct. Good morning. Just enter, is it? Good morning. So -7 meter. 65. Okay lah. 365, is it? Okay. If the student you answer two significant figure should be 6.37 lah. Okay. 4 significant is more safe for yours. Okay. So this one should be the answer. Okay. Then Esther also got answer. Esther also the same answer from here. Okay. So thank you for you to answer already. Okay, so we continue to the next part. Okay, if you want to write in nanometer, it's okay lah, 636 nanometer. So you just convert the standard form, you make it become the nano, so -9. So you move your decimal point behind lah. Then after that, they become nanometer. Okay, then we go to the next question, then should be the structure question, number 6. Okay, diagram 1 they show about the effect. Okay. Okay, yeah, I got answer already. Chris also give me the answer. Okay, so from here you can see they observe that when the electron, this all is an electron, they're allowed to pass through two slit, double slit, and also the slit, single slit. So you can see and the slit are very close. Okay, so they pass through double slit. Then they told you this one two slit is very very small slit. Okay, so this one is an info they provided. So that means electron they pass through two of the slit. Then this one slit is very very small. Finally, they get it the result like this. This one is an optical screen. Then this one is a screen front view. So you can see the arrangement just like what we learned before. There's an interference. Agree or not? Remember the light. Okay, interference. There's a bright, dark, bright, dark, bright, dark. So when the electron, they do the same process. Okay, they also find it. The result almost the same. This one is a bright fringes. Then this one should be the dark fringes. Okay, same like the light phenomena. So from here, we go and see the question, what they want to ask. Okay, what has happened, electron, after passing through each slit? The question got a little bit specific. They said each slit. They never asked double slit. Okay, they ask you what happened when the electron just go one of the slit. So anybody here got idea? Okay, what's your answer when they just go one of the slit? What happened? Okay, so we wait the student and let's see the student understand or not. So this one is one of the question about the chapter 7.1, quantum theory of the light. They ask about this one. Okay, so what do you think about that? What happened? Electron act as a wave. This one I know. Okay, we know electron also is a wave, but now they ask you what happened. Okay, you think what happened for the electron? So you can see like here. This one situation when the light just go each one of the slit only, what happened for the electron? Okay, we learned before. We learned about the wave before. Okay, recall back. When I just go single slit, what happened? Okay. So anybody here can answer me? Okay, just think about that, the wave, what we learned before. Okay, we learn phenomena, is it? I give you some of the hints for the phenomena. We learn about a reflection, refractions. Then after that, we learn about diffraction. We learn about the interference. So what do you think about that? What happened when I just go single slit? Okay, answer. Okay, I already give you all the tips already. Anybody can answer here. You just type in the chatting room. Okay. So just type only calculation, so many respond. Just a structured question the student do know how to answer. Okay, please respond. Single slit, what happened? Single slit. I keep repeated the word single slit. So what you think about the wave? Electron already is a wave. Just now the Kiran say already. So you think about this one is a wave lah. When the wave just goes single slit, what happened? Your answer or not? Oh no, wait so long already. The students still do know how to answer. Wave, single slit. So you think about the phenomena we learned before for the chapter wave. Single slit is what? All the Form 5 students forget already. The Form 4 what we learned already about the wave. Okay, so from here I just show there is a diffraction. Okay, remember, single slit is a diffraction. When double slit, just like the diagram, there's an interference. So that means the electron also can show, yeah, linear diffraction. Yeah, correct. So that means this one phenomena, they just want to show about the electron also can show about diffraction. Means what? Electron also can be wave. Okay, electron also can say there's a one of the wave, not only the particle. Okay, so we continue to the next question. Okay, Khatija also say there's a diffractions. Okay, correct, huh? Okay, now B. What is the phenomena we observe from the screen? What phenomena? Okay. Oh, Lina said Google search. Why Google search? This one you learned before that. No need to search, you also know the answer. Okay, now you go to B. What is the phenomena? Okay, you see the screen, the optical screen. Okay, so they ask you this one is what phenomena? You see the dark, you see the bright, you see the dark, you see the bright. That means that every fringes, when they just arrangement, the distance is a uniform. And this one is what phenomena? Okay, any idea? Remember the fringes from the light. We learned before the light. Okay, they also is bright, dark, bright, dark. Okay, this one is what phenomena? Okay, so you also learned before. Okay, the phenomena just like the situation we learned it. So like this. Okay, the band should be consistent. The band is a consistent. Then after that, you can see this one is a dark. Then this one like this. So that means you see the electron also same. The pattern also same like what we learned before. So this one is what phenomenal. Okay, Jaya can answer or not? This one is what phenomenal. Okay, so you can see the number 1A and B is a difference. This one they ask every slit. This one they ask screen. Okay, phenomena from the screen you observe. So this one is what phenomenal. Okay, answer please. Decay. What is a decay? Don't understand, huh? Jaya, what is a decay? Okay. So, haven't do revision. That's why. So this one we call interference. Do know. Decay, no already. That's a do know. Okay. So please, that means now, Yiru correct. Interference. That's correct. That's an interference. Okay, please recall back what we learned for the chapter 6. Chapter 5. Chapter 5 from 4. There's a wave. Must do the revision already. If not, the marks still very low. Okay, then we continue to the next part. Still question 6. Continue about the structure question. Oh, now the answer come already. Okay, we just show this one. Okay, based on the effect shown on the diagram, is the electron particle? Okay, so from here you can see from the diagram, is it the electron is a particle? So from here, the answer, if we follow the the wave particle duality, they ask you, is it the electron is a particle? Actually, yes, that's a particle. Okay, why we say electron is a particle? Okay, because the electron, they can collide to each other. Okay, so from here you cannot see like actually they got collide to the each other. When they just collide to the each other, actually they got momentum. So that means from here we can find it, electron actually is a particle. So when the question just asks you why, so you need to answer they got momentum. Okay, momentum is from who? From the de Broglie. De Broglie, they say about the particle, they also got momentum. So that's why we're using the formula for momentum, is it? So number 2, they might ask you, the electron, is it a wave? So the answer same lah. When you see the diagram, sure it's a wave already, is it? So we just answer yes, there's a wave. Why? Why you say there's a wave? Because the electron can show about the diffraction and also the interference. So then say this one, electron has a wavelength. that can show about the diffraction and interference effects. So that's why, because of these two of the concept, so we bring to the wave particle duality. So there's a from the Einstein and also the de Broglie. So they combine the photon is a particle, and also there's a one of the wave. So from here, they just take the electron. They take the electron is a one of the photon because of the mass is very, very small. Okay, so from here, this one, we just answer yes, then you need to give the reason. Okay, remember, particle, the reason is a momentum. Then if you say about the wave, then you must say about the diffraction and also the interference. Okay, we continue 6 again. Okay, name the phenomena has happened on electron in the sea. Okay, C just now. C is what? Particle and wave. Okay, now I want to combine these two together. Okay, Kaiguan memang is actually forget lah. Now you concentrate to your working already. You no need to remember this all thing already. Okay, this one just learning for the Form 4 or Form 6 student. Okay, so from here we go through to the phenomena for the C. So I want you to combine. Just now the C. We say about particle and wave. Now we combine, become one of the phenomena. So this one phenomena we call what? We call as a wave particle duality. Okay, so remember when the question asks about the phenomena related with the particle and wave, so we continue block. We combine together, they become wave particle duality. So this is one of the phenomena. Okay, E, state one important, the application for the behavior of the electron in the D. Okay, this one electron at the D means the duality. Actually, where we go to applications, we using the electron as a particle. We also using the electron as a wave. Okay, application we using the electron in wave. So the answer should be electron microscope. Okay, we apply this one for the electron microscope. So that's why they can produce a very, very high the power of the resolutions. Okay, so this one is one of the application we using the electron in microscope. Okay, then after that, the F, determine, now calculation for you already. Determine the de Broglie wavelength. They want to find the wavelength of the gun bullet. The mass is provided. The mass, which moving velocity. They provided the velocity for you. Now it's not a light, it's a bullet, gun bullet. So that means we cannot using the C 3 times 10 power of 8. No. Okay, this one they're just talking about the gun bullet. Okay, they give you the Planck. Okay, now the info we show first. V. V is a velocity of the bullet. Okay, mass is a bullet mass. Then the H is a Planck constant. Now they want to find is what? Wavelength. Okay, de Broglie wavelength. So from here, de Broglie wavelength related with the M, related with the V. But now the question never provided is a momentum. So we need to convert momentum become mv. So remember, so we just apply this formula. Okay, lambda equal Planck over mv. So the student, please answer now. We need to find is a lambda. Okay, so we just wait the student answer from here. Okay, just now, student, you can see about the Telegram already come out the link, is it? That one is a today Google form. Okay, today is a Google form. We'll give you do some exercise about the calculations. Okay, so anyone can give me the answer for the lambda is how many? Okay, we just apply only. Put in the Planck constant. Then after that, this one is a 0.02 mass. Then the velocity is a 250. So this one question, you must be careful. Okay, they're talking about bullet. Okay, they're never talking about the light. So you cannot simply, the light speed is a 3, power of 8. No, this one is another way by using the formula also. Okay, this one is from the de Broglie wavelength. Okay, Yiru give me answer already, 1.326. Okay, Jia also same. The answer should be the same, both also same. So you need to show, okay, yeah, 1.326 power negative 34. Okay, very, very small only the lambda. Okay, sorry, I think I give the wrong unit, is it? I go to change, you see. Okay, I give the unit is a ms, so should be meter. Okay, should be meter. So the answer is meter. Okay, 1.326 power of negative 34. Okay, so we go to the next part. Okay, next part is a 7. Okay, 7. What is the frequency and energy of the photon with the wavelength is a 10 nanometer? Okay, the question actually they want to find two things lah. One is a frequency, another one is the energy. Okay, then the provide is a wavelength. So in 4, C is the same, 3 times 10 power of 8 because they say photon. When they just say the photon, so we're using the speed of the light. Okay, lambda is provided. You go to change the nano, become meter first. Then the Planck, you need to memorize. Then the question, you want to find the F and also the E. Okay, so from here, we do know the E. Okay, we do know the F. So that means the first question, you find the F first. Okay, we need to find the frequency first. So from here, any idea formula you want to use? Normally, you follow the energy photon we're using E equal HF, is it? Now the problem is no E. Okay, no E, also no F. How to find? So we're using the original formula, V equal F lambda. Is it? For the photon, V equal F lambda. So from here, photon also is a wave. So that means we can using this formula, V equal F lambda. But the problem now, the V is how many? The V now is a C. Okay, follow the photon. Now the velocity is the speed of the light. So we just using frequency F equals C over lambda. Okay, the V we just convert becomes C because this one is a photon. So now you want to find the frequency. V equal F lambda, so C equal F lambda. I want to find the of the F. So C must over the lambda. So the answer from the student. Oh, just now the Linghan, the Khatijah, your number power a little bit problem, not negative 37. Yeah, they delete already. Okay, so maybe the typing or you say about the calculation a little bit problem lah. The power, you must very be careful. Okay, now the answer from here, frequency is how many? Okay, we left 10 minutes, so still okay lah. The question is almost finished lah. So from here, the frequency, okay? For the student, you find the frequency, then the next one you continue for energy like very fast only. Okay, so some student answer the first one, some student answer the second one. So this one, we no need to wait so long already. Okay, anyone for the C, for the F? For the first one, 7 for the F. Okay, later is for the energy. So we check the answer from the student. Anyone can give the answer for this one, question 7. Okay, question 7. Just typing, then we check it. Okay, many disappear. Adrian still not yet wake up. Nixon also not here. Lisa, Sharon, don't know go where already. Okay, after that, Rui-En also never see. Rui-En where to go? Okay. Tuition also not here. Okay, Mei Ling show me already. Mei Ling, they said 3 power of 16. Okay, we go to show the answer. Okay, so we apply all the things lah. Unit, everybody forget the unit. Okay, the frequency is a hertz. Yeah, correct, from the tube. Okay, they give me the answer 3 power of 16, then hertz. Okay, they give me the Hertz already. Okay, yeah, Esther F. You give me F for what? Okay, so from here we continue with the next question. After the F, we need to find it's a E lah, and G. So I no need to mention, you know what formula want to use already. There's a Planck formula. There's a E equal HF. Okay, so Esther, give me the answer for the E. Give me the answer for the E already. Just now you're typing wrong, is it? Give me the answer for the E now. Okay, E is how many? You take the Planck constant. Okay, Jaya, 989. 1.989. Okay, so from here, joule, remember the unit is a joule. Yeah, Esther, 1.989. So we go to show multiplications, finally 1.989, four significant figure, then power of -17, then joule. Okay, so this one's just a question, it's a simple question, but you need to know when they're asking about frequency, there's a photon, you must convert, the V will become the C. Okay, we got number 8. How many photon? How many photon? Yeah, Khatija also give me the answer. How many photon emit per second? The question asks about N. N is how many? Power provided. Okay, and of the light lamp. Frequency also provided. So we write the info. Power, frequency, Planck, you must know. The N, do know. Okay, so got power, you just focus to the formula for the power lah. So the power formula, okay, P equal N H F. Now the question want to find the N, so we just convert. N is here, is it? 50, and then this one is a Planck constant, then this one is a frequency. So we just want to find is a N. So the answer from the student, N is how many? Okay, we got about 6 minutes lah. Okay, N is how many? Many students on your respond. I never see your name appear here. Lena just answer one question, they go to sleep already. Ling Han said 3 multiply 16. Ling Han, I want to find is N. Okay, just now is it? You mentioned it's just now the frequency, is it? Yeah, correct. Okay, now we need to go to second question already. We need to find is a N. Maybe the line a little bit slow lah. So now I want to find the N. Anybody can answer me the N? Okay, the number photon per second. Number photon per second. Okay, so we just see here. Okay, still not yet lah. The students still not yet type here. Cannot see anything. Okay, just wait. Many of them they never answer. Okay, Esther said 1.374. Okay, power 20. Okay, so we just apply all the things. Then we find it. Okay, 374. Okay, power 20. Yeah, correct. Okay. 有开关 sudah salah leh. Never show about calculation. Yeah, correct. Your calculation is correct. Never show answer only. Okay, mailing also say like that. It's the same answer. So correct. 4 significant figure. 1.374. 4 significant figure is a 4. So Jawei, Jayao, Esther, okay, mailing, the Sikajing also correct. Okay, they show me the answer is a correct. Important is a unit must be correct. Okay, so you're going to see number 9 some more. Got so many questions. Number 9. Given that the mass of the electron, this one is the mass of the electron, now involve the electron already. Okay, what is the de Broglie wavelength? They want to find is a wavelength. Okay, of the electron beam. Can you see now? Special a bit. Got 50 eV, electron potential different kinetic energy. Then after that, the question give you one more info. 1 EV is how many joule? So that means from here, the question never provide exactly the energy. They want you to convert. Okay, understand? So that's why they give you EV, then they tell you 1 EV is how many joule. So this one, you need to do the calculation first. Finally, you find the lambda. Okay, so from here, we show the info, the mass of the electron. Then this one is a energy. This one is a kinetic energy is a 50 EV. So they give you 1 EV. Then after that, they say lambda is how many? So we need to find out the energy first lah. Okay, we find the energy first because we know kinetic energy, the formula is a half mv squared. Okay, Kai Guan, you lost your calculator 4 years ago. Never buy. Okay, so from here, you see half mv squared. So from here, we need to find out the formula for the V. Actually, V is how many from here? Okay, we just write mv equals square root 2 me. Okay, means later I need to using the mv lah. Okay, so that's why I make the mv alone. Okay, later I want to using this formula. Okay, now I go to apply. Okay, this one. Just now we do the calculation, we're using this formula. You find the de Broglie wavelength. So when I just say de Broglie wavelength, we sure we're using the momentum one because already it's a wavelength from the de Broglie. So we're using a lambda h over mv. Can you see these two mv is the same? These two mv is the same. So I need to bring this whole thing go in. Okay, bring this whole thing to go in. So become like this. Okay, lambda equal h. H is a Planck. Planck, you go to apply by yourself. Then the m is how many? M is a mass. Okay, don't forget got 2. 2 is here. So you must bring the 2 in. Then the mass of the electron. Then after that, the capital E is what? Capital E is a 50 E. Yes or no? 50 EV. So I need to bring the EV. Chain become the energy. So I need to take 50 multiply 1.6 times 10 power of negative 90. Okay, so this one question got a little bit different with the just now. Okay, so from here, you need to know this one MV, we need to convert, become this formula. You cannot say, oh, the V is a 3 times 10 power of 8. Then the mass are different. This one, they say electron, they provide the mass for you. So that means the V, you need to follow this citation to do the calculations. Okay, you cannot say, oh, V is a 3 times 10 power of 8. So you go to find the lambda is how many? No. Okay, this one question you cannot do like that because they provide the kinetic energy. Okay, so from here we need to find the lambda. So the lambda from here we get it 1.74 10 power of negative 10 meter. Okay, this is one of the questions that related with the kinetic energy. Okay, kinetic energy here. Then they show you the electron potential difference. So this kind is a one special for the question. So a student can be recalled back. Okay, from the YouTube, you also can download the question from the link just now I go to share for you. Okay, so name the phenomena that show the wave properties of the electron. Okay, now the what phenomena? Okay, the phenomena that show about the wave properties, okay, of the electron. So your answer, electron diffraction. So anyone that just say phenomena for the wave property. You can say interference. You also can say about diffractions. Okay, depend for yours because wave properties only is 2. For the electron, there can be to show the de Broglie, the concept is correct. So they only got 2 lah, diffraction and also interference. So this one is a 2 phenomena that from the wave properties. Okay, so from here we finish until the question 9 only. So today what you need to do, you need to finish your Google form for some of the exercise calculations. Okay, so no code, you just enter. After that, you just answer. Okay, remember the answer, your marks, I will record the marks. After that, they will key in for your PPT marks. Okay, the student, our class just until here only. So thank you for your response and thank you for you to enter the class for early morning today. Okay, thank you, Kai Guan also. Go to Layan my chat room. Then after that, got some of the other students also enter the class. Thank you to your attendance. Okay, so my student, we just until this part. Okay, thank you everyone. Thank you, Yiru. Okay, thank you all my fine science students. Thank you, Kai Guan. Okay, so we just stop from here lah. See you from the next lesson. Okay, bye.